Hello, my name is Alexey, and today I'm going to present you my solution to the 8 placement challenge. Before that, a few words about me. I used to work as a Java developer, but then I decided to switch into data science. For that I did a master's in business intelligence, and now I work as a data scientist at Simplex. Simplex is an ad tech company, so we work with advertisement, and this is another reason why this challenge was interesting to me. For those who listen to this at NIPS, you probably already know the details about the challenge. But for those who are listening, who are looking at this at YouTube, a few words about it before we proceed. So imagine this scenario: a user visits a website, and for the website wants to show some advertisement to this user, and there are many possible choices of advertisements that can be shown. So how do we select the best one? We select this based on historical data. We just look at how previous advertisements were interacted with, what was clicked, what wasn't clicked, and from that we build a policy which decides for the future visits which advertisements we show. And this was the main idea of the competition. So we had some historical data provided by Criteo, where we had, like for each advertisement slot, we have a bunch of candidates, and each candidate is characterized by a set of features. And also one of them, the candidate that was selected, for this candidate we know whether it was clicked or not. We know its score, propensity score, and yeah, of course the features. The features are anonymized. We don't know what each feature means. And there are a few million such candidate sets, so quite a large data set. So initially, before starting in this challenge, I wanted to follow the same approach as I did for the Outbrain competition. Outbrain competition was hosted on Kaggle like a year ago. It was also a click prediction competition, and models like follow the regularized leader and field-aware factorization machines worked quite well there, so I wanted to try them here as well before moving on to things like bandits and other counterfactual learning algorithms. What at the end I actually did, so I didn't follow the plan. What I actually did was just using this follow the regularized leader model, and then post-process output. So I didn't get to trying other things. So let's see how the model looks like. So I actually used my own implementation of the follow the regularized leader model, which was quite fast compared to, for example, logistic regression from scikit-learn, which is wrapped around liblinear, and the implementation I used previously was pure Python implementation, which was also quite slow, and this one is C++, and then binding in bindings for Python. So this is essentially the core thing of my solution. So just train the model for 22 passes, save it, apply to prediction. So about what we put in this model is that the X comes from the features, of course, and we can see that it's mostly ones, but for some of the features we have something else, not 4, so here and here. So what I did was just treating the presence of this feature as 1. So for instance, this 4 disappears and we just have 1 here. And this large binary encoded matrix is that X. This Y comes from these label columns. And this part wasn't used because the feature number 0 and 1 are present for all the observations, so they're not very useful. The reason I did this binary way of one-hot encoding is I first tried to do actually feature hashing to try to encode these values each into a separate column in the matrix. It didn't show any significant improvement on the cross-validation, so at the end I decided to follow a simpler approach, which is just taking this and putting this into a binary matrix. The way the participants of this challenge were ranked is by using this IPS score, inverse propensity score. And I didn't know about this score at all before before participating in this challenge. So my first trial was, I just took the data, I trained a logistic regression model. Since I used scikit-learn, it was very long. I needed to select the best set of the best parameter for regularization. Since there is a lot of data, it took really long time, like a day, to select the best parameter. Then the test part of the data is also large. It takes a lot of time to score the data, and then actually submitting the predictions to the platform take also a while. And after all that, like when I finally saw the score on the leaderboard, it was 45 IPS, which is basically almost the same as the random submission provided by the organizers. So I thought, okay, what's the why this happens? So I spent so much time training the model, which is supposed to be better than the random baseline, but it wasn't. So, but first let's look at how IPS is calculated for this challenge. So for each group where the click was, so we record all the candidate sets, and only those where the click was, we look at this, we look at the predictions our model produced, and then we apply the softmax over all predictions, so we have probabilities, and then the total final IPS is an average of these individual IPS contributions from each group. So the catch here is this apply softmax, and this was the reason of low IPS of my first attempt. So let's look at this. Let's look at why. So let's imagine we have this candidate set. We apply the model, like these are the features. We train the model, we apply it, and we get these scores. So my first attempt was to output actually probabilities. So it's a score, it's sigmoid applied to the score, and this how probabilities look like. So the 0, 1 is the one that was selected by the system. So it was the one that was clicked or not clicked, but usually it's the 0, 1 which was selected, and then the probability for other candidates. But once we apply sigmoid, it basically becomes uniform. So it means no matter what the model thinks, it basically uniforms all the predictions, and they contribute the same amount to the final score, which is why at the end the solution produced the same score as the random baseline. So then I thought, okay, maybe I don't use sigmoid, I just output raw scores without applying sigmoid and see what happens. Well, what happens is that after we apply softmax, it's not uniform anymore, but still it's basically almost same for all the predictions. So what we want to have is something like for things that we are more confident that are clicks, we want to have higher probability, and for these things that we are less confident, we want to have less probability. Because if there was a click, then in the formula here, we apply score of the clicked item by propensity, we multiply, and this is the contribution to the score. And here, like this was selected, the contribution is very low. So what we want to do is somehow modify the output. The pretty first thing that occurred to me that I can just take the maximal value and add some large number to it. For some cases it worked. It actually improved the score. It was like almost 50. But what happened is, like in this example, we see that like the actual thing that was clicked on received very, like, doesn't receive a lot of probability. Most of the probability is here. So we need to somehow make it smoother. And for that, I try to apply sigmoid and then multiply sigmoid by some constant. And we see that this part becomes a bit more pronounced, this becomes less pronounced, so this receives more probability. So of course we can just multiply by some larger number, like 500 here, and we see again. So most of the probability mass comes here, but still for the actual click it's non-zero. So if there is anything, so if we made a mistake here and predicted that this is going to be clicked, this part still makes sure that something is contributed to the final score. And that, of course, can be, these two approaches can be combined. We can take sigmoid, multiply by something, and then add some value to Argmax. And this is what I actually did in my solution. So my solution is that. So I train, follow the regularized model, follow the regularized leader model 10 times to reduce the variance, and then take the average, and then I apply post-processing. So that I take the raw output, add some small number here, multiply by a constant, and then I add some value to the argmax of the output. These constants were selected with cross-validation, so this is quite large value, and this is 15, this is a very small value. And this solution was my final one, which was which gave the IPS of around 55 and 6. So some final thoughts about this competition. So is the model useful for organizers? Probably not, because my first attempt and the last attempt, they are almost the same models. Because if I just use follow the regularized model, follow the regularized leader model, and also output probabilities, that is 45, and if I go through all this post-processing, is 55. The model is the same, but post-processing is different, hence different scores. But I don't think the model was completely useless, because to get to 55, the model should actually predict some clicks correctly, because if it didn't, then the contribution of each group would be 0, so it wouldn't be very high score. But it's still, it wasn't a counterfactorial learning model at all, so it was usual supervised learning classification, still online, because I used this online classification model. But it wasn't what the organizers wanted us to try. Yes, I know that. What I think would be helpful for the next challenge, maybe to have some reinforcement learning friendly environment to make it work, because like when we actually apply the model, we want to receive some feedback from the system. Okay, this was clicked, this wasn't. And if we don't have this, the usual classification models, I think, will produce better results than bandits and other things. So for bandits to work better, there should be some way of recording reward and then updating the model when applying it. Here are some links to the challenge. So my solution is available here. I also posted a report to archive, and if you have any questions, you can always reach me on this address. And of course, for these competitions, for this competition, there is a Gitter channel where you can also write any questions, and I can check it and give the answers there. Thank you very much. That is all from me. Bye.